Hello students, welcome to lesson 16 on trigonometry. I hope you are all doing well. Good. Now, after watching this video, if you realize that there was a concept you did not understand, do not hesitate to give me a call for further explanation and clarification. My number is on the flyer on your screen. Pick the number up and give me a call. Right. Now let's begin our lesson. Good. Now in our previous meeting, we looked at trigonometric ratios of 0 degree and 90 degrees angles. Sorry. So we summarized the trig ratios of 0 and 90 in a table where we saw that sine 0 is 0, sine 90 is 1, cos 0 is 1, cos 90 is 0, and tan 90 0, whilst tan 90 undefined and tan 0 what? 0. Good. So you have to know all these ratios of what? Of the 0 and 90 degree angle, in addition to the 30, 45, 60 angles. Okay, because they come often in trigonometry problems. Okay, in trigonometry problems. Good. Right. So today we are not going to focus on trig ratios, but we are looking at a different thing. Okay. So what we'll be doing today is angles in standard position. So we'll be looking at angles in standard position. Right. So let's look at that. Good. So angles in standard position. Angles in standard position. Now in geometry, we learned that an angle is formed when two rays meet at a point. An angle is formed when two rays meet at a point. Good. So if we have this ray and then we have this ray, okay, they are meeting at this point. Okay, so the angle is formed between this ray and this ray. This is the angle. Okay, now this ray, the starting ray, if the rotation is from that one, is called the initial ray. Initial ray. It's at times also called the initial arm. So either the initial ray or the initial arm. And then this ray, where the angle ends, okay, it's called the terminal ray or the terminal arm. Okay, good. So the point of intersection is called the vertex. The vertex. So this is the angle theta. I hope you get it. So that is what we learned in geometry. Angles are formed when two rays meet at a point. So the point of intersection is vertex. The starting ray is called the initial ray, and the ending ray is called the terminal ray. So it is the terminal ray because that is where the angle terminates. Okay, that is where the angle terminates. Good. Now, if the rotation is from the initial to this point, then we say that that is a positive angle. Okay, so positive angles are drawn moving in what? In the anti-clockwise direction. I'm taking it again. Positive angles are drawn moving from what? Anti-clockwise direction. So that is that. This will be a positive angle. Okay, a positive angle. So the starting ray is what? The initial ray. The ending ray is called the terminal ray, and the point of intersection what? The vertex. Good. Now we want to know what it means to say that an angle is in a standard position. What does it mean to say that an angle is in standard position? So let's look at that. Good. So an angle is said to be in a standard position if its vertex is at the origin, initial arm at the positive x-axis, and terminal arm either in a quadrant or on an axis in a Cartesian plane. So initial arm, terminal arm, quadrants, and then Cartesian plane. So these are the key words in the definition. So an angle is said to be in a standard position if its vertex is at the origin, its initial arm at the positive x-axis, and terminal arm either in a quadrant or on an axis in a Cartesian plane. In a Cartesian plane. Okay, so we want to know what a Cartesian plane is, because angles being in standard position is just angles in the Cartesian plane. Okay, angles in the Cartesian plane where the terminal arm is on the positive x-axis, the initial arm in a quadrant or an axis, and the vertex at the origin. So let's look at that, a specific or illustration of an angle in standard position. Good. So this is the Cartesian plane. This is the Cartesian plane. Now it's basically intersection of two real number lines. Okay, it's basically the intersection of two real number lines on a plane. That is basically the Cartesian plane. Good. So the horizontal number line, okay, the horizontal number line is called the x-axis, and the vertical number line is called the y-axis. Okay, good. Now you know on the number line, numbers to the right, okay, are positive, and then numbers to the left are negative. The same thing applies to this one. So numbers above here will be positive, and then numbers below here will be negative. Good. So that is with the Cartesian plane. So this will be the x-axis, this will be the y-axis. Now when you look at it again, there is a point of intersection between the two axes. Now this point, if the coordinate is 0, 0, we say it is the origin. Okay, the point of intersection here, if the coordinate is 0, 0, we say it is at the origin. So our own, from the definition, this point of intersection should be 0, 0, and that is the origin. Okay, that is the origin. The point of intersection here is the origin. Good. Now you can see that the plane is divided into 4 sections. This one, so this section, this section, this section, and this section. So 4 sections. Okay. Now the section has a name. So 4. There are 4 of them. Okay. So they are called quadrants. Quadrants. So in a Cartesian plane, there are 4 quadrants. In a Cartesian plane, there are 4 quadrants. Now this A is the first quadrant, the B is the second quadrant, C is the third quadrant, and D the fourth quadrant. First quadrant, second quadrant, third quadrant, and fourth quadrant. Good. So the Cartesian plane is divided into 4 quadrants. Okay, good. Now the standard way of labeling the quadrant is using the Roman numeral. So we don't use alphabet. Standard wise, we use the Roman numeral. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. I hope you are okay with it. So we know, we've seen what a quadrant is, we've seen what an origin is. Okay, good. Now you realize that this y-axis and this x-axis are perpendicular, so there's an angle formed between them. So that angle is 90 degrees. So a quadrant, the measure of the angle of a quadrant is 90 degrees. So this is also 90. This is also 90, and this is also 90. Okay, so from here to here is 90 degrees. 90, this one is also 90, so this place will be 180 degrees. Okay, this place will be 270 degrees, and then this place will be 360 degrees, because we are moving around 4 times. 90 plus 90 plus 90 plus 90 will give us 360. So here will be 90 degrees. And then the starting, you can start from what? 0 degrees. I hope you are following. Good. So the measure of an angle in a quadrant is what? 90 degrees. Good. So take note of all the information I'm giving you, okay? They are very, very important. Take note of them. Good. Right. So let's move on. Let's move on. Let's move on. Good. So now, we want to draw our angle in standard position. Good. So this is the positive x-axis. Okay, so our initial arm or initial ray will be here. Okay, so this starting point will be what? Our initial arm or initial ray. So we call this one the initial ray or what? Or arm. And then also if we draw another ray here, okay, pardon my diagram. If you draw another ray here, now this ray, because it is terminating here, if we start our measure of direction from this initial arm and then we move this way, we are ending on this ray. So this ray will be what? Our terminal what? Terminal ray. Okay, terminal ray. Okay, so this is what? Our terminal ray. It is our terminal ray. I hope you are following. Good. So it's just some terms we want to be familiar with. Good. So let's do it this way. So it is what? The terminal ray. So that is where the angle what? Terminates. Good. So initial ray, terminal ray, and then the angle is here. Now the point of intersection, we said it is what? The vertex. The vertex. The vertex. The point of intersection is this region and it's what? The vertex. Good. Now we are moving in the what? In the anti-clockwise direction. Okay, we are moving in the anti-clockwise direction in the measure of what? The angle. So we started with the initial arm or ray and we moved in what? An anti-clockwise what? Direction. So this is our theta. Now pay attention here. If the rotation of the angle is in an anti-clockwise direction or rotation, then the angle is a positive angle. Okay, so positive angles are drawn in the anti-clockwise rotation what? Direction. So when you move this way, you are moving in what? Anti-clockwise direction against the way the clock moves. And then if you are moving this way, you are moving in what? The clockwise or direction. Now positive angles are drawn in what? An anti-clockwise direction. Okay, and negative angles are drawn in what? Clockwise direction. So negative angle will start from the initial arm here and move this way. Okay, and move this way. That is in the clockwise direction. But at our level, we'll focus on only the positive angle. So we'll always be drawing our angle moving in the what? The anti-clockwise direction. I hope you are okay. Good. We'll be drawing our angles in what? The anti-clockwise direction. Good. So students, I think we've exhausted all the key features in the definition of an angle in what? A standard position. The initial arm is at the positive x-axis. The terminal arm can be in a quadrant. So in this diagram, the terminal arm is in what? In the second quadrant. And then the vertex is what? At the origin. Okay, good. So now let's draw specific angles in standard position for us to get the understanding better. Okay, good. Right. So sketch the following angles in standard position. Sketch the following angles in standard position. So we have 60 degrees, we have 110 degrees, we have 210 degrees, and 300 degrees. So I will do the first two, and then you will do the last two. So pay attention whilst I'm drawing, and then you'll be able to do the last two. Good. So this is our Cartesian plane. Now 60 degrees, we said that a measure of a quadrant, the angle measure of a quadrant is what? 90. So if this is our initial arm, then our 60 degrees will be in the what? In the first quadrant. Okay, our 60 degrees will be in the first quadrant. Good. Now it is not drawn to scale, but you should let us see, or your diagram should depict what? That the 60 is more than what? Half of what? 90. Okay, good. So you have to bear that one in mind. So let's see how it is drawn. So you only need your terminal arm because your initial arm is just the what? The positive x-axis. So you draw your terminal arm of what? 60 degrees. Good. I'm coming in. I want to get some perfect diagram. Okay. Right. Good. So this is my terminal arm. So from here to here is what? 60 degrees. So this is the initial arm and this is what? The terminal arm. So this is an angle of 60 degrees in standard position. Right. So let's move on. Good. So 110 degrees. 110 degrees. Good. So always our initial arm, we don't touch it, but we just add a terminal arm to it to form our angle. So 110 degrees, we said that from here to here is 90. So it means that we have to add an additional angle to the 90 for us to get what? 110 degrees. So what must be added to 90 for us to get 110 degrees? It's 20 degrees. Okay, so you add 20 degrees to 90 degrees, you get what? 110 degrees. So let's draw that. Let's draw our terminal arm. Okay, with an addition of 20 degrees. Okay. Right. So pardon me, 20 degrees. Okay, good. So we'll do the correct diagram. So 20 degrees. So we should start from here. Okay, don't. Mine is not being smooth, but you get it. So this is it. So this small angle here is the 20 degrees that we added to the 90. Okay, is the 20 degrees that we added to the 90. So this small angle is 20, then this one is what? 90. So 20 plus 90 will give us what? 110 degrees. I hope you get it. Good. So which quadrant is an angle of 110 degrees in? In the second quadrant. Good. It's in the what? Second quadrant. Good. Right. So students, now it's your turn. Do the last two and let's see. So the last two, the angles were 210 and 300 degrees. So do that one. Do that one. Pause the video and then do that. I'm giving you 2 minutes to do that. Okay, good. So time is up. Now let's see how 210 and 300 looks like. So this is 210. This is 210. Good. So 90 plus 90, 180. And then you have to add a small angle to 180 for you to get what? 210. So what must be added? 30 degrees. So this small angle here is what? 30 degrees. Okay, good. Let's look at 300. Good. So this is 300 degrees. From here to here is 90. From here to here is also 90, so 180. Then from 180 to here is what? 90, so 270. So you need a small angle to add to the 270 for you to get what? 300. And this small angle is what? 30 degrees. Good. So students, I hope you've gotten the concept. you now can draw angles in standard position. Right. So this is where we'll end our lesson for today. Now, I would give you an assignment for you to practice so that you build your confidence. Okay? Good. So let's look at the assignment. Good. Sketch the following angles in standard position. So 45 degrees, 135 degrees, 225 degrees, and 315 degrees. Right. So, till we meet again, revise, read ahead. Bye.